Ladies and gents, we are starting 6.3. We're talking about how can we graph these lines. So we've practiced a lot with graphing from y equals mx plus b form, and we've converted from standard form to y equals mx plus b so that we can graph it. But there's another actually pretty easy way to graph things that are given in standard form. So first thing I'd like you to do is just review with me what are the two forms of a line that you've learned.
Linear, non-linear.
Okay, so you know that.
Or straight.
Yeah. So you know that a graph can be a linear or a non-linear. That's fine. But I'm just asking for lines, the equation of a line. Thank you. So what's that form called?
Y-intercept. No, that's the slope.
Slope y-intercept form. And what's that again?
Y equals mx plus b.
Where m is the and b is the. Thank you. And the second form that we learned about last lesson?
ax plus by plus c.
Yeah, it's called
Standard form.
standard form. And sorry, go again, Jaden.
ax plus by plus c equals.
Good. And the important thing here is that it's always set to equal 0, and that the coefficient of the x term is positive, and that either a or b can be 0, but not both of them at the same time. Okay? Now, there is another form that's really, really helpful. Okay, I'm going to give you two examples. I'm going to give you an example of a line in slope y-intercept and an example of a line in standard form. So here in y-intercept, jot down this line, negative 2 over 3 times x plus 8. Now I'm not going to show the math, but we can rewrite this in standard form. It would end up being 2x plus 3y minus 24 equals 0. Okay, they're the exact same line. So if you had to graph either one or convert them back and forth, this would work out. It's the exact same line. It's just written in a different form.
How does that work out?
Okay.
Why there's nothing with y?
There is a third form for a line. It doesn't have a name, but it's really helpful for graphing so that when you're in standard form, you don't have to convert to y equals mx plus b before you can graph. You can graph it in one less step. Okay, so that form is this, and you'll see how I came about it once you see it. This part's not changed. 2x plus 3y equals positive 24. What did I do to get that next form?
Did you do the times of 1?
No, you.
You just added 24 to the 0.
All I did was add 24 to both sides. Okay? Piece of cake.
No, you're done? No.
This form, if you should have space either underneath or to the right, doesn't matter. This form has no name, but is very helpful when graphing. And here's why. Because we can graph from knowing the x and y intercepts of any line. So for instance, this is my axes, x and y. If I can find out that, let's say, this is just a random case, but let's say I can find out that the x-intercept is 3 and the y-intercept is 2, then what can I do?
Draw a line.
I can draw a line through those 2 points. Okay? So let's take a brief note on how do I determine the x and y intercepts. Listen to this. The x-intercept occurs where y equals 0. We'll make sense of that as we move along. You should already know that really, and you have an idea of that. Where y equals 0, that's where it's going to cross the x-intercept. That's where it's going to cross the x-axis. And the same is true for the y-intercept. The y-int occurs where x equals 0. So I find where x equals 0, and wherever the line crosses, that's my y-intercept. I can explain this using coordinates as well. Look at the coordinates of this point that we drew for the x-intercept. It's 3, 0. Where y is 0, x is 3, therefore that's my x-intercept. Down here, the point is 0, 2. Where x is 0, y is 2. Therefore, it's my y-intercept. Okay? So that's what we're going to be practicing today. We're going to dive into a few examples. All right, example 1, calculate intercepts. So again, we're breaking it down into stages. We are going to be able to graph lines by the end of this lesson, but in order to do that, we need to be able to figure out what each intercept is so that we can graph our line through 2 points. Joanne loves reading. She has $48 to spend at her favorite bookstore. She likes comic books, which cost $4 each, and novels, which cost $6 each. Write an equation to model this situation. So first things first, let's think about the situation. Are there any variables in play here?
Yes.
What are the variables?
For money and how much the book costs.
So she has $48, and we know that for sure. Is that a variable?
No.
No.
But
We
six
know that the
bucks
books... Is a novel going to cost $6 one time and a different amount another time?
No.
No, so it's not varying at all. What's varying? Keep thinking about it. The number of each type of book that she buys. Not the cost of each book, the number of books that she buys, okay? So, we should have 2 variables because there's 2 types of books. Somebody pick a letter.
7.
No.
7.
Let's look at the problem. Choose letters that make sense.
C.
N.
for
Let
comic.
C be the number of comics purchased. Somebody pick another letter. Let N be the number of novels purchased. Okay. Joanne is going to spend $48. Okay? So, she's going to do that by spending some money on comic books and some money on novels. Or maybe she'll buy all novels. Or maybe she'll buy all comic books. We don't know. What we know is that 4 times, and then I'm just going to write this in brackets, 4 times the number of comics plus 6 times the number of novels is going to equal $48. 48. Okay? So what this means is that we've identified that the comics are each going to cost $4, but we don't know how many she'll buy. And the novels are each going to cost $6, but we don't know how many she'll buy. But we know she's going to spend $48. Now let's rewrite this using our variables. We've got 4C plus 6N equals 48. Okay?
We have to get N by itself.
No, slow down. Now what we're going to be doing here, this is a difficult, just in your minds you're going to have to kind of convert. We didn't use X and Y, okay? We could have used X and Y. We could have said let X be the number of comics, let Y be the number of novels, but we didn't. So what we're looking at when we get to our graphing point is that we are going to have the number of comics and the number of novels, okay? So our line is relating N and C rather than X and Y. That's okay, because it's helping us understand the problem. So now I need to find the intercepts. So now I'm looking for the C intercept, and I'm looking for the N intercept. Okay, and if I can find where the dot for the C intercept would go and where the dot for the N intercept would go, then I have 2 dots and I can graph my line. I have 2 points. Okay? So here we go. Determine the X and Y intercepts of the equation. So in order to do that, maybe what we'll do first is we'll scratch what I said earlier. We'll convert this into X's and Y's. Okay? So it'll be more helpful for you. So instead of C, we're going to use X. Instead of N, we're going to use Y. Still equals 48. No big deal. Haven't changed anything. I just changed the name of
Why do you
these
know
variables.
Which one is X?
Okay?
Yeah.
Why can't 6 be X?
They're both dependent.
Well, 6 is 6. You could ask me, why can't N be X? That's fine. It could be. It doesn't make any sweet bit of difference. In this case, neither one of them, they both depend on each other, really. They're equally dependent in this situation. Okay. Kind of 2 columns are going to happen. So first we have find X int. And sorry, where do we find the X intercept? What's Y doing at that point? Y will be 0, okay? So find the X intercept by setting Y equals 0. So I'm going to copy my problem down. Maybe I'll be consistent with my colors. 4x plus 6 times 0 equals 48.
So it's just 4x equals 48.
So it's just 4x equals 48 because 6 times 0 is 0. Now I divide both sides by 4. 48 divided by 4 is 12. Okay, so now I have found out that the x-intercept is 12, which tells me also that the point 12, 0 is on the graph, because when y is 0, x is 12. Okay? We're going to do the same strategy, but we're going to find the y int by setting what?
X equals 0.
Setting x equals 0. So now I have 4 times 0 plus 6y equals 48. Notice I just took my original equation again. First I put it in here with y equals 0, then I put it in here with x equals 0. Okay? Follow it through. 4 times 0 is, so I'm left with 6y equals 48. Y equals 8. Which tells me that the point 0, 8 is on the graph. It's really that easy. So now we're going to go to our graph. You're going to find the point 12, 0, which is on the x-axis over here at 12. And you're going to find the point 0, 8, which is on the y-axis up here at y equals 8. And now that you have 2 points, you can grab your ruler out and carefully draw a line through those points. And you've now graphed the equation 4x plus 6y equals 48. Let's discuss what this line really represents. What does this mean for Joanne?
How many, the amount of bugs she bought increases your cost.
Well,
What?
thanks. Okay, so this graph, the cost that she spends is not going to change. She's going to spend $48. What does this line represent? So remember, one of them was comic books, and one of them was novels.
It will cost us
If she doesn't buy all, if she only buys one type, right?
So these dots represent if she only bought novels or she only bought comics. But what's all this
the
space in between?
possibilities.
All the possibilities. So if I went down here at however many comic books this is, and then she would be able to buy this many novels.
Oh.
Okay, if she bought this many comic books, less comic books, she'd be able to buy more novels. If she bought more comic books, she'd be able to buy fewer novels.
Oh.
But all along, she's maxed out at $48.
Would it be if she bought more?
Okay, example 2 says use intercepts to graph a line.
Oh, we're still doing that?
So for each linear relation, determine the x and y intercepts and graph the line. So in example 2a, we're given the line 2x minus y equals 7. Now, this is not in standard form. It's not in slope-intercept form. But we can easily calculate our intercepts. So how do we do that? How do I find the y-intercept?
Like getting to the y zero.
Find y-int by
X zero.
setting
X something.
x equals 0. Here we go. 2 times 0 minus y equals 7. Negative y equals 7. Y equals negative 7. Super fast.
Complete.
Okay?
Give me a second.
So-
to comprehend.
Yep. All we did from here to here is multiply 2 by 0, which gets us 0. And all we did from here to here was multiply both sides by negative 1. Or divide both sides by negative 1. X is 0. So we're not multiplying, we're not multiplying x by 2.
So-
We are, but x is 0.
So X is 7, or no, Y is 7. 7, 7.
So the intercept, the y-intercept, is negative 7. Okay?
Okay.
Somebody finish my sentence for me. Find x int.
By setting y equals 0.
We're so smart.
By setting y equals 0. Great work. So I copy my equation again from the top. Now I've got 2x minus 0 equals 7. Sorry, what's 2x minus 0?
0.
2x. If you start with 2x and you don't take away anything, you just have 2x. And now divide both sides by 2. Watch this one, because this is going to trick you. Just, you could do 3.5, or you can just leave it as 7 over 2. Okay?
Oh, and then you can use the 7 over 2 to find.
Alright, so now we have our 2 points. So I'm going to write a statement. I'm going to say, therefore, the y-intercept occurs at 0, negative 7. So therefore, 0, negative 7 is on the line. And over here, 3.50 is on the line.
Can you just do the 7, or can you do 7 up 2 across to find out what the... like
Nope,
the-
that's not the slope. We did not find the slope. This has
Find the
nothing to do with
y-intercept.
slope. We found the intercept. So 7 over 2 is just a number.
If it's
Okay,
7 over 2
when
is
you're
3.5,
graphing it-
then you'd find the 0.
Nope, 7 over 2 is 3.5. So your point is at 3.50 on the y-axis. So the steps are, first, plot your points. Then draw line. So up here we have our y-intercept, is 0, negative 7. So we got 0 down here at negative 7. And over here our x-intercept is at 3.5. So you find 3, 4, 3.5 is in between there. Now you have your 2 points. Grab your ruler out and draw a straight line through those 2 points. And as always, we label our line. This is the line, 2x minus y equals 7. The line that we need to graph in B has one more step that we need to do, and you should be able to see it right away because you recognize the form that this is in. What form is this given in?
AX minus BY.
What's that form called? Standard form. So the first thing we actually need to do in this one is convert to our other form. And actually we don't even have to do that really. Let's just do it the same way we did it before. We'll do the exact same way so we don't have to think about anything else. Find x int by
Setting y equals
good, and that's so easy I'm not even going to write it anymore because you know how to do that. So we're going to set y equals 0. So we've got 3x minus 5 times 0 plus 15 equals 0. Disappears, right? What's my next line look like?
It doesn't just
3x plus 15.
Thank you. Jenna, next.
Then you divide by 3, take 3 from
Minus
or
15.
minus
No,
15
no,
from
look
both
at it.
sides.
Oh, you
Yes.
guys are buckling under the pressure. I'm rushing
No.
you and you're buckling under the
Minus 15
pressure.
from both sides.
Leaves me with 3x
Jenna.
equals negative 15.
What?
What?
Olivia?
Jenna doesn't understand.
Leave me with x
Negative.
equals negative 5. Okay? Therefore, negative 5, 0 is on the line.
Where did you get negative 15?
Swap the 15.
Subtract 15 from
Oh,
both sides.
Yeah.
Okay, find y-intercept by,
Setting x at 0.
so we got 3 times 0 minus 5y plus 15 equals 0. Jaden, what's my next line look like?
Negative 5y plus 15.
Carry on.
And then
E.
equals negative 0.
Good. Maddie, next line
Minus 15.
from both sides. So what am I actually going to write?
Negative 15. Negative 5y equals negative 15.
Good job. Sam?
Negative 5 divided by 5.
So I'm going to divide both sides by
Negative 5.
negative 5, which is going to leave me with
3.
y equals
3.
3. Therefore, Emily, what would I say?
Negative 3, 0 is on
0, 3.
Good. 0, 3 is on the line. So now to graph it,
We can do the graph now.
I find my point negative 5, 0. And I find my point 0, 3. And get out my ruler and graph a perfectly straight line. Label my axes, label my line. The line is 3x minus 5y plus 15 equals 0. That's the equation of the line.
How does that equal 0?
Last example, example 3, really quickly. Determine the slope of the line whose x-intercept is negative 4, whose y-intercept is negative 6. There's two different ways to do this. The one is just thinking algebraically. Okay, if we know that the x-intercept, so this is method 1, algebraically, if the x-intercept is negative 4, then what point do we know is on the line for sure?
Negative 4.
Negative 4, 0. If the y-intercept is negative 6, then what point do we know is on the line? 0, negative 6. Well, guess what? Now, in order to find the slope, we can just use our equation, y2 minus y1 over x2 minus x1. We can plug in our values. Let's say this is 0.2, so we've got negative 6 minus 0 over 0 minus negative 4. Okay, we plug those in the right spots. So we have negative 6 over 4, which reduces to negative 3 over 2. Done. Slope is negative 3 over 2. Okay? The other way would be to graph it. I'll just draw it really quickly. if it goes through negative 4, 0, and it goes through 0, negative 6, then the rise over run
You see, that's what I was trying to
is
say last
negative
time.
6, 4. So rise over run is negative 6 over 4, which reduces to negative 3 over 2. So either one of those strategies will get you the slope. Okay? Do you have key concepts there? Or no? Yep, key concepts. I'm going to just read for you, fill in the blank. The x-intercept is the x-coordinate of the point where a line crosses the axis. At this point, y equals
Zero.
0.
What was
The y-intercept is the y-coordinate of the point where the line crosses the y-axis. At this point, x equals
0.
good. X equals 0. For some equations, it is easy to graph a line using intercepts. For example, in the line 3x plus 2y equals 6, when x equals 0, y equals 3. And when y equals 0, x equals 2. So then you would plot the two intercepts and draw the line through them. Your practice problems are there for you right on page 15. You can do them in a notebook, okay?
Yes, sir.